So we are going to do a review on forecasting. We'll look at data cleaning. And for hypothesis testing, I think, okay, we did that last time. That's the thing I actually wanted us to look at. You should be able to identify the type of test. Look at the question and try to identify the type of test you are expected to do. The two popular kinds of tests, particularly parametric tests, the two most popular, even if it's not parametric, they are mostly test of mean and test of proportions. Okay. So you should be able to decipher between them. Okay. So we'll also look at some non-parametric tests as we move ahead. But I just want us to tie up these things so that because we have reached an advanced stage in this course now. So let's look at a review of forecasting. Now, when forecasting, what are the major techniques? What techniques did we look at for forecasting? We talked about regression analysis. Is that not so? We talked about what else? What else did we talk about under forecasting? Oh, dealt with forecasting. What else did we talk about? Do you remember moving average? We talked about moving average. What else? We talked about, I hope we remember these things. We talked about weighted
moving average.
Yes, weighted moving
average.
Yes. Talked about weighted moving average. Weighted moving average. We talked about that. Okay. There's also what we call exponential smoothing. Exponential smoothing. So these are ways of doing forecasting. Yeah, but it's very important to know the difference, okay? These three belong to the same category, sort of. This belongs to a different category, okay? Why? Because when you are talking about these three, we are talking of, just a minute, let me load let me open let me open another workbook. Let's see. Can you see the others? What sheet are you seeing? Are you seeing a new sheet? Are you seeing a different sheet now?
Yes, sir.
Yes, sir.
Okay. So let's see. Let me go to regression. Okay, regression. Okay, now.
I'm not going to erase it.
Now, there's something you should notice. There's something you should notice. When we are dealing with regression, we always talk about comparison of variables, not just one variable. Okay. For example, I know we use this as an we use this solve this kind of problem when we're talking about regression. Here we're trying to compare, not compare. We're trying to explore or discover the relationship between publicity expenses and sales. And where we identify publicity expenses as the X, which is the independent variable, while sales was identified as a dependent variable. So you see, when you are dealing with regression, you are talking about, relationship between variables, like in this case, between X and Y. Where one variable depends, where a change in one variable depends on a change in another variable. Okay, so that's what happens with regression. Okay, so in such a case, you are able to forecast what the value of the dependent variable would be for any given value of the independent variable. So that's the kind of problem you solve with regression analysis. Okay. But when you are dealing with moving average, it's a different ball game. It's a different ball game because this time you are talking of you are just looking at one variable like this, okay, and you are trying to explore the trend in that variable. The trend, you try to discover the trend, and based on that trend, you try to forecast, make forecasts based on the trend, make projections based on the trend. Okay, so that's what happens when you are dealing with when you are working with moving average, weighted moving average, and exponential smoothing. Yeah. Okay, so let's come back here now. So now we've already identified that regression. I think we spent some time on regression, so we already know what regression is about. Then for moving average, I'm saying that it's quite different, sort of. It's also for projection or forecasting, but the way it is used is sort of different. And and you need to also understand that um, there's something you should also understand when you are dealing um, with moving average, weighted moving average, exponential smoothing. There are some assumptions you make which is different from regression. Okay. Now, for example, when you are working with this now, take for instance a situation where actually there's expenses, various expenses on adverts, okay, and that influences sales. Okay. Now, if the advert is what is influencing the sales, and there's a strong relationship between them, it will be better you just use regression for such a problem. But if all such important factors are kept constant, Okay. Then you may be talking of moving average and the rest. Do you understand? So because otherwise the trend will be affected. Because if another factor is what is influencing this change, apart from time or seasons or whatever, then regression will be a better way to go. Okay. So that is that. Now, this exponential smoothing, I don't think we really gave an example of this. Let's just do that now. Let's say we want to use exponential smoothing on this data, for example. You can use, instead of calculating manually, you can use the data analysis tool for your exponential smoothing. Okay. So I just go to data analysis. All right, so now it has opened up data analysis. Dialog box has opened up. So now you choose exponential smoothing, click OK. What is the problem again? Okay, so it has opened up. It's asking for, I mean, we should be used to this dialog box now. Okay, because we've seen it several times. It's asking for input range. You just click in that box there, highlight the input data. Okay, then damping factor. This needs explanation. Now, this damping factor. Now, suppose I use I will explain what I mean by this. Suppose I use 0.2, for instance, as my damping factor. Okay. What I'm saying is, don't worry. By the time the output opens up, you'll see what's the effect of that. Now you choose a damping factor. Your damping factor should be a fraction like this. Okay, it's shouldn't be more than 1. It should be a fraction like this. Okay. Of course, I didn't select headings, so I'm not choosing labels. I go to output range, just click where I want the results, and then I click OK. If you want more information, you can check these ones. Click OK. So it has done my forecasts for me, projections, my forecasts. So now, sales forecasts. So first of all, you just observe that the first thing he does is, here is not applicable. He couldn't calculate any forecast here because forecast is always computed based on past data, right? It's always based on past data. Okay. Then this second line too, he couldn't do much because exponential smoothing uses both past actual and immediate past actual and past forecasts to compute the current forecast. So what it simply does is it picks, it's only this sales that's or actual that's available here. It picks that as the forecast. So the real forecast calculation starts from this line. Okay, this shouldn't surprise us because forecast is always based on historic data. It's always based on data that already exists. So the real forecast calculation begins from here. I want you to notice what's, just observe what happens. Let me display the formula. Can you see that? What did I choose as my damping factor? Do you remember?
0.2.
Thank you.
0.2.
0.2. So that 0.2 is this 0.2 that you are seeing. 1 minus 0.2 is 0.8. Okay. So what it does is the 0.2, it applies 0.2 to, rather, it applies 0.2 to the forecasts, previous forecast for the previous period. Okay, assuming this is month 1, month 2, month 3, month 4. So in doing the forecast for the third month, it needs to use the second month actual and forecast. Okay, so since I chose 0.2 as my damping factor, I'm saying that it's just like weighted average now. It should apply a weight of 0.2 to the previous forecast and then apply 0.8, which is 1 minus 0.2 to the previous actual. I don't know if you are getting me. So it's saying 0.8 times the actual for the period, which is this one, this L5, 0.8 times L5 plus 0.2 times M5. Okay, that's how I got that. Then this one is now using this one. Please, are we following? Applying the same formula, 0.2 times M6, 0.2 times M6, which is this position. That's the previous month's forecast. Multiply by 0.8 times L6, the previous month's actual. Okay, so it makes sense to apportion more weight to the previous actual than the previous forecast. Okay, it makes more sense that way. Okay, so these are the results is given to us, and of course there's variance. There's variance there. Just like I've already explained to you, in forecasting, you do a little bit of experimentation. You try different methods. Whichever one works best, you then adopt that. That's how to do it. Okay. There's no hard and fast rule to it. You just, at the beginning, there will be some element of trial and error. Then what works best for the business or for the data, your type of data and the type of trend in your data, you apply that. Okay, so is it all clear? Is it clear, please? Can we proceed? Can we?
So the 0.8, where did you say it comes from?
Yes, I said, you see, you are trying to apportion weight to actual, previous actual, and previous forecast, right? Now, the total weight you are apportioning is 100%, which is 1, right? 100% is 1. 100%, that's all 1, right? So what we are saying is, now you have to split that 100% or 1 into 2 parts. You apply, you apply one part to the actual and apply the other part to the forecast, right? Forecast of the previous months, okay? In this case, or the previous time or previous period, okay? So when we're doing this thing, we use the damping factor of 0.2. I'm saying that 0.2 is applied to the previous forecast, right? Then 1 minus 0.2 gives you 0.8. That 0.2 is like 20%. We are saying 20% should be multiplied by previous forecast. The remaining 80%, which is 0.8, should be multiplied by the previous actual. Did that answer your question? The
Yes,
0.8
sir.
came about because we chose 0.2 as our damping factor. Okay. So 1 minus 0.2 gives you 0.8.
Okay, sir.
Okay. Okay, so that is that. Okay. So now let's just is there any other question? Is everything clear to every one of us? From here, I hope you can see that these three actually, the exponential smoothing actually belongs to the same category as the moving average and weighted moving average, in the sense that
Okay, so the same
it,
pattern.
yes, it applies to a simple trend, a simple data trend of data. Okay. Which means we're actually dealing with one variable, one straight variable, which is sales in this case. Or in the case of regression, you are dealing with multiple variables, okay? Yeah, well, let's just use that opportunity to talk about something more about regression. Now, regression is used for finding out the connection, the relationship between two variables. But we should know that that relationship is measured in terms of what? What do we call the measure of the relationship? What do we use to measure the strength of a relationship? Correlation, right? We use correlation to measure the strength of a relationship, isn't it? Correlation. It's what we use to measure the strength
Yes.
of relationship between variables. So how does correlation differ from, how does it differ from regression? How does it really differ from regression? Okay, because some people mistake correlation with regression, but they are not the same. They are different. Okay, even though they are related. Actually, you cannot talk about regression without talking about correlation. Whenever you talk about regression, you always talk about correlation because they sort of work together, right? But when you are doing regression analysis, it goes beyond just measuring correlation. You are trying to see a connection between variables, right? So that goes beyond just measuring the correlation. So let's see how that works. We'll see how that works now. Okay. In a few moments.